This definitely goes under the category of easy peasy, lemon squeezy. This is probably the second easiest lecture of the year. All right, good way to end this week. If given a chemical formula, I can determine the percentage composition of each element in the compound. All right, now that we know how to write chemical formulas, at least most of us do, and if you don't, you're in big, big trouble and you really need to learn how to do that. Let's put them to good use. There are ways of getting these things to give us relevant information. Now remember that in chemistry, if we can't measure it, we usually don't like it. We don't like describers like ginormous and minuscule. We like numbers. We like quantitative analysis. Okay? So many mathematical relationships can be deduced by using chemical formulas and chemical equations, which is the next thing we're going to study. This study into the quantitative nature of chemistry is called stoichiometry, where metry is the Greek word for measurement, and stoichios is the Greek word for, I don't know. No idea. Sorry. One of the things in which we can do with stoichiometry is percentage composition. What is percentage composition? Quite simply, it's the percentage by mass of all the different elements that make up a compound. Okay, look at Stefan. He's football quarterback, right? Okay, football player. I bet you that Stefan can figure out what percentage composition is all about. Okay, Stefan, if I was to say to you, Stefan, find the percentage by mass. Find the percentage of guys in this room. How would you do that? Count up everybody and then count up all the guys. Then divide the guys by the total number of people. And then multiply by 100. Folks, I mean, I know that you were thinking, well, if he had asked about the linemen to come up with that, then it would have been much easier. But Stefan, I mean, quarterbacks, they're not as bright as the linemen are. Okay? Everyone knows that. Linemen are more intelligent than quarterbacks and receivers, right? Because the linemen have to know what's going on everywhere. So actually, for your information, if you're into football, by and large, the linemen are the only ones in the NFL team that actually have degrees. Most of the others do not have degrees. All right. He's absolutely correct. That's how easy it is. Why is it that we find the percentage composition for different compounds? Well, one of the most relevant and practical ways of applying this is in the mining industry. Every bit of copper that we use, we have to import from other countries. Does anyone know why? What? Every bit of copper that we use, we have to import from other other countries. Does anyone know why? Yes?
It's cheaper to import than it is to mine another.
It is cheaper to import. Do you know why?
Because of what's on the slide right now.
Okay. There's at least 3 big ores. These are compounds, rocks that contain copper. Each one of these ores has a different percentage of copper. The one that has the highest percentage, which I'm not sure, but I think it's called malachite, we've run out of here in America. We have plenty of copper. Normally people, when I ask that question, will say, we've run out of copper. No, we've not run out of copper. We've got a ton of copper. We got a ginormous amount of copper. But the copper is in ores that have a low percentage of copper in them. So you get much smaller bang for the buck. So you not only have to pay union wages and pay people at least minimum wage, but you're not even allowed to use slave labor like other countries use. So it is much cheaper to use other countries' copper because they have more malachite than we do, so they sell us their malachite. Unfortunately, because we have to import the copper, then it makes it far more expensive. So housing prices have gone up because of this percentage thing. Okay, so how do we do this? This easy. Carbon dioxide. First thing you need to do is write a correct chemical formula. Carbon dioxide, correct? Then it's as simple as using our metaphor. Find the number of guys, find the number of girls. Stefan, how do we find the number of guys? No, right now we're adding up the total number of people. What's the mass of carbon? Quarterbacks. What? Plus 2 oxygens, or 2 times 16.0 equals 32 plus 12. All right, so Stefan, what do we do now? How do we find the number of percentage of boys and girls? Yes, boys and girls. Who cares? What? Divide 12 by? This would have been a whole lot easier if I'd asked the lineman.
The lineman in here is right. Now your point is?
The lineman is smart. He might be lazy, but he's smart.
Peyton Manning, he's a quarterback. Probably
It's because the linemen probably give him pointers.
he has to have a
12 divided by 44. Let's get back to chemistry. 12 divided by 44 times 100 is
27%.
1 decimal place. Alec, if we want to do the Sig Digs thing right, 1 decimal place. 27 point. I think it's been 3.
Oh, yeah, it's 3. It's 3 because you have to round. So it's 27.
And I bet you the other stuff is 72.7. How was I able to figure that out so fast? It has to equal 100, gang. It has to equal 100. So all I did was subtract it from 100. All right, let's do one that's slightly harder because there is no hard on these types of questions. Well, actually, the hardest part is probably coming up with a correct chemical formula. Max, potassium dichromate.
That would be
Potassium is symbol and what charge?
plus 2? No, plus 1.
I don't know. Why isn't your periodic table out?
Had it out. Yeah, plus 1.
Dichromate.
CR2. Yes. CR04.
Wait, is it dichromate?
It's dichromate.
Dichromate. CR207.
Charge.
-2.
Do you understand now what I meant by this is the hardest part of the whole problem? So what is the formula? Max? Formula?
The formula max?
No.
No, you're Max, and I need the formula.
Okay. So we start with the total and then I'm not
Okay. What is the formula of K plus and Cr2O7 negative
okay,
2?
You already had it written. I see for someone else. It's KCr2O7. K2CR2. Gotta remember those.
Okay.
All right. 2 potassiums, Max.
39.1 times 2.
Plus 2 chromiums.
52.0.
Plus
And 16.0 times 7.
this is 78.2. This is 104. I don't know what that is. I think it's 112, but I'm not sure. Calculator, Max. 7 times 60. 112. All right, Mr. Max. 78.2 plus 104.0 plus 112.0 equals. Max, trying to get him to redeem himself.
294.2.
Okay, so what do we do with that number, Max?
We divide each separate mass by that number and then multiply times 100.
All right, Elizabeth, you're going to do the first one. Molly, you're doing the second one. And Noah, you're doing the third one. First one, Max. No, Elizabeth. Elizabeth's doing the first one. Point 6. Second one, Molly. Last one, Noah. Might want to add those up. 26.6 plus 35.5 plus 38.1. If they don't equal really close to 100, maybe a little over, a little below, then you've done something wrong. Which one's wrong? Well, that's pretty close to 100. Right, because here's the problem with this is these formula masses are rounded numbers. So 100.1 is going to be okay. 99.9 is going to be means you've done it right.
What about 98?
98, you may want to check your math.
What about 100.2?
You might want to check your math. All right, so here's your